the course GIS to ensure a sustainable future. And GIS means Geographical Information Systems. And our presenter today is going to be Dana Husingfeld. Dana grew up mostly in the Middle East and Europe as a child of diplomats. And at doing so, she saw a lot of different geographic areas and cultures and so on. And this sparked an interest in how different cultures interact with the environment and so on. And she saw a lot of different environmental impacts. And this impacted her and what she wanted to study. So she went to Hope College. And what more can you say about somebody, right? So she graduated from Hope College with a Bachelor of Science in Geology. After her graduation, she worked for the US government in Washington, DC for a number of years, utilizing her specialties in her education. And then she did geographical research in Europe, in both Belgium and in Spain. Most recently, she's been working for an environmental agency in Boston, Massachusetts. And she decided to go back to grad school after that. And she just completed her master's degree from Western Michigan University. And her degree is in GIS, Geographical Information Systems. And actually, during that semester, this last semester, she taught a course at Hope College. So she graduated from Hope College and taught at Hope College. It's quite a good combination. She's looking forward to continuing her work in sustainability and geographic information systems, and especially focused on environmentalism. She has a passion for the environment, for sustaining our world, and is looking now for a career in sustainability. And so I'm going to turn it over to Dana Husingfeld.
All right, well, thank you very much for that introduction, and good morning, everyone. I appreciate you all listening today. So let's go ahead and get started. I'm going to share my screen. Okay, and start slideshow. Maybe, Paul, could you just verify that you can see my presentation? Okay, great. So let's start. So today I will be presenting on using GIS to ensure a sustainable future. To quickly go over the topic we will be discussing today, I will start with an introduction to GIS, what they are and how they work. Next, I will discuss what sustainability means to me and how we can come at it from a GIS perspective. Then we will go over several different examples of how GIS can and is being used to address sustainable development, as well as some prospective uses of the technology in the future. And finally, if there is time, I can present some recent work that I have been doing on the topic. As you can see, I've also thrown a few question and answer breaks in there. Since we are on Zoom, if a question comes up while I'm speaking, you can write the question out in the chat window, or write that you have a question in the chat window, and then I will call on you once we get to one of those next Q&A breaks. As you mentioned, maybe you could do one of those reactions. One of the issues is that I'm not sure if I will be able to see it or not, but I will try to keep an eye out for it in case anyone has a question. Otherwise, I will definitely try to answer everything during these breaks. Okay, so let's start with talking about GIS. What is GIS? As Paul mentioned, GIS stands for Geographic Information Systems, but there are many ways to actually define exactly what that technology is and how it works. Some definitions include as I've listed here, a computer system for capturing, storing, checking, and displaying data related to positions on Earth's surface, or a framework for gathering, managing, and analyzing data. Or another one is a system designed to capture, store, manipulate, analyze, manage, and present all types of geographic data. These are all quite wordy, but are essentially identifying the few main functions of what a GIS is and why they are so useful. And so I think that that's why the definitions focus mainly on what it does rather than what it is, because that's why we use it. And so why do we use GIS? At its base, what GIS allows us to do is create geographic data, manage that data in a specialized database, analyze the data to find relationships and patterns, and finally to visualize that data on a map. Therefore, the definition I use the most is this: a software system that allows for the creation, management, analysis, and visualization of geographic data to reveal patterns or relationships. And I'll go into more detail about this, don't worry. But how is this done? Before we talk about how it's done, we need to talk about what geographic data is. Geographic data is literally, it's very simple. It is any piece of information that has a location. For example, we have the obvious ones, such as a location based on GPS coordinates or your home address, but also any physical feature that we know the location of, such as a river crossing through multiple counties, a utility line running beneath a building, or a watershed between multiple mountain ranges. But geographic data can also be demographic, such as your nationality. So you as a person are tied to a certain country, or your household income, where a monetary value is linked to your house's address. It could also be the name and date that an ancestor of yours immigrated through Ellis Island. That name and that date and time are tied to that location. Of course, lastly, it could also be, well, not lastly, there's thousands of things it could be, but it's the age that you listed on the most recent US census. And since we're on the subject, I'm going to take a quick commercial break to talk about the US Census. If you have not completed the 2020 US Census yet, please do so. It is incredibly important and provides so much helpful information, not only for city, state, and federal use, but also is one of the largest and free databases for geographic and demographic data in the United States. I used it extensively in my thesis and know of thousands of other researchers, students, admin officials, NGOs, as well as environmental and social justice groups that use this data all the time. It really is a fantastic resource. You can see on the right here just how many types of information it collects. And really, the greater the participation, the better the data. Okay, commercial break is over. So now that we know what geographic data is, how does GIS actually use this data? How does it work? GIS takes these different data sets and layers them on top of each other so that we can view multiple types of data at one time. So in this graphic here, you can see that there's a street data layer showing where the streets are located, a building data layer, and a vegetation data layer. What GIS does is it integrates these layers into a visualization of the real world in the correct location in space, as you can see on the bottom right, that these three different layers are brought together. And this also means when we can do this, it means that we can analyze these data against each other in true space. So they're no longer separate layers, they're combined and integrated into one. Here is another example where we see all these different layers of geographic data, including the top layer says customers, that's rather, just people, a location of different people, street and parcel locations, and then we have elevation, and then land usage data below that. Again, these layers are all stacked and integrated together into a representation of the real world on the bottom. And this is how we end up with products like this. So this should probably look familiar to everyone. It's just good old Google Maps. So if you didn't realize it before now, if you have used Google Maps or Apple Maps or really any type of interactive mapping search, then you have used a GIS. Okay, so don't worry about this graphic too much. It's just quickly to sum up what a GIS is. It's really just this centralized software system that allows you to do all these different geographic processes at one time and in relation to each other. So let's talk about sustainability. What is sustainability? I find personally that it helps to define sustainability first, since I do think it is a term that is used a lot today to cover a very broad topic. Sustainability at the base is really just the ability to be maintained at a certain rate or level. So the term just means to say the same, but I think for the most part, we don't, as the human race, want things to stay the same. We want to develop and grow, hence the term sustainable development. And although most people use the term specifically when referring to environmental sustainability, sustainability can actually be described as three main pillars. There's society, environment, and economy. In other words, people, planet, and profit. So let's look at this a little bit deeper. So here we see a simple graphic showing the three pillars of sustainability. The issue here is that the topics are completely separate and look like pillars holding up the roof of sustainability, but we know that these topics are not actually fundamentally exclusive from each other, and they actually overlap significantly. I'm going to take a quick break just to check if I'm missing anything. No, okay, we're all set. So here we see a very simple graphic showing the three pillars of sustainability. Again, except this time it takes these relationships into account, that these things overlap with each other. And where the three meet, that's where sustainability is, or more likely when sustainable development can occur. But my issue with this viewpoint is that it still shows these things as separate, they just overlap, which I think can and in fact does lead to addressing sustainability from these different directions rather than holistically. So in reality, I believe this graphic best expresses how these three pillars relate to each other. A sustainable economy is only possible in a sustainable society, and a sustainable society is only possible in a sustainable environment. So those three last slides might have seemed a little repetitive, but I think it's important because understanding and respecting the interrelation of these pillars leads to a more holistic and effective study of sustainability. And this is where GIS fits in really well here, because it's clear from this graphic that we need to consider these three pillars together, and GIS is capable of holding all these different types of data and allowing for analysis between them while still respecting the relationships that these things have with each other. So let's pull this all together and look at where GIS fits in. To illustrate this, let's look again at this graphic. Here we see these layers of different types of data that combine to show us a picture of the real world. The top three levels show us where people live and how they travel and move through an area based on streets and road networks. The next layer brings in the environment and the topography of the land. And then finally, land usage, which can explain not just the environmental side of things, but also economic information. For example, if an area is industrial, agricultural, or natural forest. So this way, we can study how many people live in a certain type of land use area. Excuse me. So how many people live in a certain type of land use area. But now let's try adding some different data. So we replace customer locations with data on each individual's race and replace elevation data with income data. Now we can look for geographic patterns regarding race, income, and land usage. So do certain races trend towards certain income brackets, or are certain income brackets more likely to live in industrial areas? So this is the same tool, GIS, but with different data, and we can answer completely different questions. Okay, we'll do one more replacement. Now we replace customer location with income data for each individual and replace the elevation data with data for access to healthy food and grocery stores. Now we can look into if there are any patterns between income level, food security, and diet-related health issues, all within the same tool that is GIS. Okay, so now I will take a question and answer break. Let me stop sharing. Okay, does anyone have a question? If you have a question so far, you can put it in the chat or speak up. Try to unmute you.
Well, I had a question. You say that GIF is software.
Yes.
But you need to get the pictures, particularly in the land usage and that kind of thing. Is that done with photography, or is it done with drawings, or, you know, you're integrating the data with the software, but where does
That's a great question. Actually, yeah, the data comes from many different sources. That's a good point. The imagery, of course, most imagery will come from satellite images, but there's certainly, you know, photographs, they can be brought in. You can really bring in almost any type of data. The raster or the vector data that we have in terms of the shapes of the streets, that is typically built or created in GIS. It's just held as digital data. I would say that for most of the points and the locations. One thing that's very nice about GIS, at least for points, it doesn't work as well for like a road network, but for points, if you have the coordinates, just like the longitude and the latitude of points, you can bring those coordinates into GIS and it will create those points on a map for you. So really the data can come from a lot of places. It can be tabular data. Imagery is, of course, a very big one, or the vector data that is created in GIS itself.
Mm-hmm. Yeah. Okay, thank you.
Yep. Any other questions before we move on? Just remember, if you have a question, to unmute yourself. Okay, I think we can move on. So let me share my screen again. Oop, wait, did we lose our spot? There we go. Okay. Okay. There we go. Thank you for bearing with me while we make sure we're working. Okay. All right. Well, thank you for that question. So let's start talking about some examples now of how GIS is being used to solve sustainability issues. So we will first start with some examples of GIS and how it's being used. And I realized as I was building this presentation that trying to walk you through the process of how GIS analysis actually works is probably not going to be that helpful. It's quite technical, and anyway, there are really a lot of different GIS softwares and technologies available. So instead, I will just show you very briefly the one that I use the most often, and then focus on examples of how other people, other researchers have used GIS to solve sustainability problems. So I use an ArcGIS software from Esri. This is probably the most well-known company in software, but it's also quite expensive. So it's more often used by private companies and academic institutions than by individual users. There are free software options for GIS, but today I'll be focusing on this particular program. And also, one reason I wanted to bring this up, certainly if you know someone, if you are, or if you know someone who is interested in going into GIS and into the geographic field, this is really the particular software that you will want to know and do some research on if you hope to work in the field. It's the premier software right now. Oh, why is it not? Okay, sorry about that. So this is a screenshot showing the main interface of the software. The map view, which is, you know, correctly scaled and exists in real space, if you will, is in the middle. Excuse me. And all the tools and folders surround it. And they can actually be moved. It's very helpful that everything can be moved and customized to the user's preference. But don't worry too much about what it looks like. And it does look, I had someone say that it looks a little dated, and that's true. This program hasn't changed visually very much in the past decade, mostly because once you know it, it's really nice to keep it the same. But there are newer, fancier versions of this software as well, that if you learn from that first, it's a little easier to pick up versus completely changing where all the buttons are. So in order to actually create, manage, analyze, and or visualize geographic data in this system, to use this GIS, we use what are called tools. And this screenshot shows just truly a fraction of all the different tools that are available in Esri ArcGIS. Here in the middle, you can see a small portion of them, but there are actually at least 200 different tools that you can use, which means over 200 processes that you can do against geographic data. So that's actually all I'm going to show you about the program itself. I can say after spending this past semester teaching GIS at Hope College, we didn't even cover a portion, like a fraction of everything that we could have talked about. So of course, we're not going to get very far if we try to do it today either. I just wanted to show you quickly just how robust this program can be. Okay, now let's look at some examples of how people have and are using this technology to study and address sustainability issues. We'll start with a few examples of environmental sustainability. This is a screenshot actually from a web map created by researchers at the University of Utah, showing the renewable energy potential across the United States. Excuse me. Now, renewable energy, of course, is a very important and big topic when we talk about environmental sustainability, because it's linked to energy resources that are continually replenished without a negative impact on the environment. It includes sunlight, wind, water, and heat, particularly geothermal heat in this situation. Using GIS, they were able to analyze the energy potential for geographic locations based on these natural resources, and therefore could determine where sustainable efforts could be the most productive. So you can see across the top here, try it with my mouse, that they actually have separate tabs and maps. And unfortunately, this is just a screenshot, but if you go to the actual website itself, you can click on these, and there are maps for each of these different energy potentials across the United States. But it was through using GIS that they were able to not only analyze the potential for energy production of each resource, but they were also able to combine these, as you can see in this particular tab, into a single layer showing which states have the best combined potential for renewable energy production. So this is just one example where GIS took this incredible amount of data and different types of data, and researchers used it and combined it in order to be able to identify the best and most effective locations to pursue large-scale renewable energy production. Here we see a map showing the low-lying coastal areas that will be most affected by sea level rise. As sea level rises, certain areas will, of course, be more impacted than others, and GIS enables us to analyze where these areas will be, so politicians and officials and NGOs, funding programs can plan accordingly for this. This also shows the power of GIS, that these researchers were able to run this analysis for the entire globe once they collected all the data, rather than having to do it piecemeal and piece it together. And of course, GIS can also help us to project long-term changes in sea level and visualize the impacts, which can be seen here in this map of what the Earth would look like if there was no land left. Okay, that was obviously a joke. I had to fit one in there somewhere. I don't think anyone actually used GIS to make this. And then anyway, this map shows the areas in the United States that have the highest numbers of rare species that are either endangered or critically endangered. Here, GIS allowed researchers to analyze the density of these endangered species and produce a quick and clear visual of what areas need the most attention and where funding and programs can be focused first to protect critical biodiversity. And one final map for environmental sustainability. This is one of my favorite maps that actually exists. This map visualizes the total areas of the different land use types in the United States. Of course, they are not conveniently set up in these big blocks geographically as shown here, but GIS was used to analyze land use data over the entire country, and the total area of these different kinds were calculated. Next, GIS was again used as a visualization tool to refit these areas into the boundaries of the US to help viewers understand just how much of the land here is used for different industries. I think the most shocking one here is just how much of the US land is used for cow pasture and range, and that so this is the big orange is cow pasture and range, and that the area for livestock feed here looks almost close to double the amount of land that is used to grow the food that humans directly eat, like plant material. Thought it was a very, very powerful map. Okay, so now let's look at GIS and society or societal sustainability. So of course, conflict, whether it's civil or international war, has a significant impact on stable and sustainable social development. This map shows the major conflicts since 1990 around the globe. It is interesting to note that there has not actually been any analysis here by GIS, but that GIS still allows for powerful visuals to be created, showcasing in one image multiple types of information. I'm going to admit someone quick. Right. So this map, in one map, we see where the conflicts are, what type of conflicts they are, the area that they influence, and the amount of military expenditure in the country. It wouldn't be difficult to analyze these data separately, but together, it's a much more powerful story. And we could, if the researchers wanted to, they could go take this to another step and actually run statistical analysis on it to see if there was geographic patterns between how much is spent on the military and the occurrence of major conflicts. Okay, why is just one moment, technical issues? There we go. Right. I also think it would be fair to say that freedom of press is an important part of societal sustainability and development, especially as it has ties to freedom of speech in general. And this map shows a press freedom rating across the globe in 2017. The blue countries are more free, while the dark purple are less free. What I find really interesting and shows the power of GIS, though, is that you can see that using this program allowed researchers to also include some temporal data. As you can see, these graphs here are the small graphs that actually show the change of press freedom through time. So for example, looking at Venezuela, where's my mouse? There we go. You can see that it was actually partially free earlier in the mid-90s, but has been slowly decreasing ever since. So in one map, there's a lot of information. Well, this map should probably look familiar to everyone by now. It shows the total number of confirmed cases of COVID-19 by country as of mid-March. However, I just wanted to kind of show this quickly because we've all seen this one, but I think a very less common map that I found that was very interesting was this one. This map shows the total number of ICU hospital beds by, I believe this is by county. And this information is extremely critical for health departments and planners as the pandemic began to spread. This helped to identify which areas were at the most risk of running out of proper hospital beds, or as you see within the dark red, so down here in the bottom right, actually is 0. The dark red shows where there are no ICU hospital beds. Of course, this data really only matters if there are infected persons in the area. So it would be helpful, they could be used for analysis if you overlaid this information where most of the COVID-19 cases are being found to find out which areas need the most critical attention and need more hospital beds than others. Okay, and lastly, we're almost to a question and answer break. So lastly, let's look at some examples of GIS and economic sustainability. Here we see a map produced by the European Union showing the location of disasters across the globe and the location and amount of funding allocated in 2018. Again, there isn't much actual analysis done here, but GIS still provides a powerful visual of where certain types of disasters are located compared to where the highest amount of funding is going. So again, further analysis could be done using this data to see if the funding is being allocated efficiently, if previous funding has made any changes with the effects of the disasters in different areas. And I should point out at this point that if you haven't noticed it already, most of the previous maps are not really just one pillar within the sustainability, but are actually a mix of economic, societal, and environmental issues. Of course, this one is a very good example of that. As we mentioned and talked about earlier, they all intersect each other. And these maps are mostly economic, you could say, but there really is no way to completely separate. Just a minute. Well, there's really no way to completely separate these pillars from each other when it comes to sustainability. Sorry, every time. There we go. So another aspect of economic sustainability is wealth equality. I think we've probably all heard about this. And we've all heard the term, the top 1%. But what's interesting, what I found very interesting about this map is that it doesn't just show location of the majority of the 1% and the bottom 99%, but rather that it's showing the ratio, which is an indication of wealth disparity that's indicated in the worst ones are the ones in the dark brown. So this is a good example of the functionality of GIS. That first of all, you could do all of this math outside of GIS and just bring the data in and visualize it, but you can also do all this computation in GIS itself. It really has incredible computing power. And so very quickly, it's very easy to see which states have the highest wealth disparity. Okay, and finally, let's quickly discuss the future of GIS. So I right here, current and future uses, and that's because much of the future of GIS application has actually already started and is just going to continue to grow as it and other technologies develop. And this is definitely not an exhaustive list. The first one I want to mention is that there's already a huge leap when GIS helped us shift from hard copy maps to digital maps. Already now we can have our cell phones speak the directions to us as we're driving, and then even offer several different routes depending on how we want to get there, or if new information about an accident occurs, it can reroute us. Next is data depth. This is just going to explode. The digital interactive maps already hold so much data. So if you're ever using Google Maps and you click on the location of a restaurant, for example, immediately it'll bring up links to their website, menus, photos, the hours that they're open, their phone number, and so much more. And there's only going to be more and more and more data added to this. Then real-time mapping. The technology behind real-time mapping is also going to increase significantly. And this is mostly due to the need of it and the requirement for it. As technologies such as self-driving cars or drones increase, they're going to need the constant local road and weather condition data and in time and in space. And so this will really continue to develop. And then one final thing is that mapping isn't and it won't be just for the experts anymore. More and more companies are developing user-friendly software and, of course, much cheaper software and apps so that anyone can build an interactive map and share their data and be part of that creation of information. Okay, so we'll do another question and answer break. Are there any questions? That was a lot. I apologize. Trying to check.
Okay, I have a question.
Yes.
Well, it's not really a question, but I love Google Earth. I love Google Maps. I live by them. I just can spend hours on Google Earth. And I love a paper map. And it's not just my generation, I don't think. It gives me a bigger picture.
Mhm.
And it's really hard sometimes to see the relationship between things without a paper map. So I hope they don't go away.
Yes, actually, that is a very, very good point. And what's funny is I don't know if for my generation, I might also be a little odd. I love paper maps as well. I also think something that has been lost, the amount of data has exploded, but I think that we've also lost some of the artistry and the cartography skills, that there is something about map making and cartography that just isn't seen in the digital view and in Google Maps. I think that there will, well, I hope that, and I believe that there will always be a place for paper maps. It might no longer be in the road map version, but there's all kinds of maps being created all the time. And I really hope that we don't lose that skill set and focus too much on data. As you could see from the maps that I showed, of course, Google Maps is one of the examples of an interactive map and a digital map, but you could also see that in some of those maps, there was a lot of cartographic skill there and care for the visual of data and effectively showing that. The other part of it too is that the one thing that, of course, I mean, there's lots of benefits to Google Maps, but the changes that I'm not old enough to not remember, or I'm not young enough to not remember the paper maps, is that within 2 years, they could be completely obsolete. And so you would have to replace them. And if you were accidentally took the wrong turn and couldn't find yourself on the map, you were running into a gas station to find directions. So Google Maps has its place, but I agree. I really hope that we don't lose the hard copy and the ones that are more cartographic principled maps. So, thanks. Any other questions or comments? Thank you for that. Comments are also great. I appreciate that as well. Okay, from chat. Can you recommend any mapping apps for vacation planning? I heard there are some to minimize travel planning groups. Ooh, that is a very good question. Let me think about that. So for vacation planning, I have to say that maybe I'm not actually the best person to ask for different types, because I have to admit, I go to Google Maps for everything. But I think that something for vacation planning is that since GIS is growing, yes, Jim, I will do that next. Since GIS is growing and becoming more user-friendly, I think a lot of websites are trying to integrate it more into their websites. More companies are trying to integrate it. And so for mapping apps for vacation planning, if you're planning to go somewhere in particular, to a certain state or to a certain national park, if you go to their websites or websites just specifically for their tourism, chances are is that they have a map created. It might either be a PDF or it could be an interactive map specifically for that area, for the different resources that they have. I know, if I'm guessing probably a lot of people during this quarantine have been looking for things to do and to go out and be outside, since we can't really go to crowded places anymore. And so over the past couple months, my family and I have been finding a lot of really good trail maps of different trails within Holland, Michigan. And they don't just pop up on the internet. We had to go to the website for that city park or for the trail park and find the maps there. So I think the mapping app, I can't give names specifically other than Google Maps, other than going specifically to websites for the locations that you're going to and seeing what map products they've created specifically for those areas. And also enjoy your vacation if you're going somewhere. Next, okay, Jim, can you show the income disparity map again and explain it? Yes. I have to make sure that I share my screen. All right. Oh, you know what? Let me, just one second. Let me make sure that I actually bring this up well. Okay. Come on. There we go. Oh, okay, that didn't work. Just so there we go. Okay, so the income. What this map is showing is that it's the ratio of, you know what, let me open, I'm going to open up the little videos over here so I can see. So what this is showing is, we've seen maps of perhaps where, I'm sorry, let me get a drink. Of where the richest residents live, and we've seen maps of poverty. But what this is showing is that it's showing a ratio, a comparison between within each state, the richest, how many of the richest 1% live in that state, and then how many of the bottom 99, I say poorest, but 99 is not, you know, there's plenty of people who are not poor in that bottom 99. And so it's showing the ratio between them. So what that means is in states like Florida, and I think New York is the highest at 45.4, I believe. So in New York, what that means is that New York has the highest percentage or highest number of top 1%, as well as the highest number of bottom 99. So the disparity is the greatest in the state, which means the income that you have some people making extremely high incomes, and there's not as much in between versus the people making very low incomes, versus a state, let's see, maybe West Virginia is low at 14.2, or Iowa is kind of low as well. That means that the income ranges are a little closer to each other. And so in Indiana or in Iowa, you don't have as many really rich people and then really poor. It's more a mix of people that are within a closer range to each other. So I'm not sure if that, sorry, going between sharing. Does that, so Jim, did that answer your question?
Dana?
Yeah.
Could I, let me see if I can explain this. On the map, New York was 45 times.
Yeah.
So let's just say that 99% of the population makes $50,000 a year on the average. So the 1% would be 45 times that, correct? So it's a huge disparity between the 1% and the average of the 99.
Okay.
In other words, there's a lot of really rich people there that just got loads of money.
Yeah. Or there's not very many really rich people, but that one really rich person is much richer than the average not rich person. So, okay. Well, thanks for that. That was helpful. Thanks. Okay, so next, Michael Seymour asked, how about data below the ocean surface? That's great. Actually, there is a ton, that's bathymetry data. There does exist a lot of that information. I didn't use any images, but if you can probably just search in Google GIS bathymetry data, and we do have it. I think we have it for the entire globe. The resolution might not be very good, but we do have that information, and that is used a lot. I have used that information a lot for what's that term called? For surveys.
A correlation between. Oh, I'm sorry.
No, go ahead. Go ahead.
Seems to be a correlation between on that map between population density and people with the lowest ratio.
Oh, yes.
You know, West Virginia, obviously, and some of the western states have a much lower population density. So there's a correlation there too, isn't there?
Yes. So let's, yeah, we can, just 1 second. So Mike, did I answer that? Hopefully I answered that question for you about the data below the ocean surface. So it does exist, and there's a lot of really information, good information. And if you look up images of it, there's some really, actually very beautiful images. At Lake Michigan, we have some bathymetry data for Lake Michigan. That's also really cool. Great, thanks. Okay, let me share my screen and we can go back to this. Yes, so this one, it's true actually. If you look at which maps, you know, or I mean, which states, we have California, New York, Florida, Texas, and also I think other than Wyoming, Wyoming kind of stands out to me, but the other states do make sense. These are very rich states. You know, these are, there's a lot of what these states have some of the biggest cities in the country and hold a lot of the wealth, and so it does make sense, and it's true. It's also can easily be linked to population density, except for Wyoming. If anyone knows why what's going on in Wyoming, I'd be interested.
And a lot of wealthy people retire there, but
Maybe, I'm not sure. Oh, okay, Jim answers favorable taxes. Well, there you go. That's true. That's a great point. And actually, that kind of brings up a good topic, is that sometimes the map that we create and that map that we just saw is not always the last piece of information. That might just be a jumping off point. You get to that map and you find something and you're like, oh, there's a pattern here that we're seeing, but it's not really explained. And then you can use it to go further into more research. And in this case, luckily, Jim kind of could tell us that it's favorable taxes. So it'd be interesting with that map. And then if you added in data about perhaps, you know, tax flexibility and see if there's any patterns that exist there. So, any other questions? Okay, we will move on. So actually moving at a really good pace. Hopefully I'm not talking too fast for anyone, but let's, oops. Okay, I have to share my screen. Bear with me, I am not sure. There we go. Sorry about that. Zoom disappeared from my screen. Okay. All right. So thank you again for all those questions. I appreciate it. And we can have more questions at the end. So let me wrap up this presentation by talking about my recent project. I wanted to talk about this project, and it's actually the one that I did for my master's thesis very recently. What I was doing is I was researching the capability of using historical hard copy maps. So this brings back the beauty and how much I like hard copy maps. And I was using them to see if I could identify potential contaminated areas in the city of Grand Rapids. And the theory behind this was that we know the industries and polluters that exist right now. They're listed, we can see them, you know, sometimes we can smell them, or we can see the big black smoke coming out of their pipes. But if we look back a century, it is likely that many of the industries that existed back then, or other locations that had contaminant activities across the city, are actually no longer in the landscape, that they've either been rebuilt or repurposed or demolished completely. So by using GIS, I was able to collect the data of these industrial locations and bring them into the digital scope and then use them for analysis. So this image here, these three here that you can see, are scans of hard copy maps from the Sanborn Map Company from 1912 and 1913. Some of you may have heard of that company before, Sanborn Map Company. They are actually, they made maps for fire insurance purposes in the mid to late 1800s and then the early 1900s. And they just hold an incredible amount of data for almost every single structure that existed at that time when they made these maps. So here, I apologize, it's kind of blurry and hard to see, but here you can just see how much information these maps had on these structures. And you can see here, let me get my mouse, this hard to see, these black rectangles here are steam boilers, and so we know the exact location of where the steam boilers were. This is a dry kiln. These is lumber sheds, and then this is a furniture company, the William A. Berkey Furniture Company. And each room, it's not just the building, it shows each room, what was occurring in that room. And so some rooms had varnishing, or veneering, or cabinet creation. And so the activity that was occurring in this exact location is present on this map. But what GIS did is that it allowed me to take this data that exists on a printed hard copy map and bring it into make it digital so that I can use it in my analysis. So I was able to bring these in, and what I did is I took the scan sheets and I brought them into GIS and located them, kind of pasted them, if you will, to the ground based on the modern streets and intersections that they exist at. And then I collected each data for each structure, or in cases like this, for each room within a structure, including what type of industrial activities took place. And at the end, I had a database of locations of every industrial activity in the city in 1912 and 1913, or at least according to these maps. And I'll show you, I'll talk about this more in a second, but what this data allowed me to do, as you can see here, is that it allowed me to learn about patterns of household income as well, in addition to industrial activity. I could take this data and use it for household income across the city based on housing type. For instance, tenements and flats would be considered low income areas, while houses, especially those with separate car garages, would indicate high income areas. This is, of course, an assumption I'm making. I believe it's a fair assumption between high income and low income. So here you can see on the left a map of the low income housing density. And so the way that I did that was that just GIS allowed me that wherever there were a point that was considered low income housing, I ran a density analysis, and GIS produced this map which shows where the densest areas or the concentration of low income housing were. And then on the right, I did the same thing, but for industrial sites. And so, and then once this was created, using GIS, I overlaid these two layers. I don't have a nice picture for that, but I could overlay these in GIS, and then I ran a statistical analysis on it to see if there were any statistically significant patterns to where low income housing was and where the industrial sites were. And unsurprisingly, there definitely was a pattern, a strong pattern between the presence of low income housing and the industrial sites, which is evidence for environmental injustice in Grand Rapids in the early 1900s. Now, to be perfectly transparent, I also ran this analysis between high income areas and industrial sites. And there also was a correlation between those that makes sense. Even rich people need to live near where they work. But the correlation was much bigger for the low income areas, which means in the early 1900s, if you were poor or if you lived in low income housing, you were more likely to live in an industrial area. And then Finally, GIS, another functionality of GIS is that it allowed me to take this data and share it with the public. I was able to create a website through it, and I will actually go to the website now. Since I will take a quick break because Michael asked, how did you code the old maps for your database? Michael, could you explain that question? What do you mean by code? Do I need to unmute?
Okay, I unmuted. Can you hear me?
Yes.
So you see a picture on a map of a boiler or a lumberyard. How does that get into the GIS database so you can?
Oh, I see. Okay.
Because the picture itself wouldn't necessarily, of the map, wouldn't translate as data
Yes.
that would be sorted or ranked.
Yes. That is, thank you for that question. Actually, I should have mentioned that. So one thing is that the GIS, the geographic data, as I mentioned earlier, that geographic data can be anything. It can be your house's address, or your age or something like that. Well, obviously your house's address, like the text next to your house address, doesn't mean anything to GIS. GIS, all that matters to GIS is the coordinates, just a latitude and a longitude. But what GIS does is it functions as a table, so that longitude and that latitude, there's a table or some text that's connected to it, and that's where it can hold data. And so this point in space, for instance, let's say Ellis Island, that's just numbers to GIS. It's a longitude and a latitude, but in GIS, it can also hold text data, and with that text data is, a field, let's say, if you can think of Excel and the columns, that there's a column for the address location or the name of the location, which would be Ellis Island. And then another field would be name of immigrant, and then your ancestor's name would be there. And then another field would be date of immigration, through Ellis Island, and it would be a date written there. So it's, if that kind of answers your question, that the coding is that the point in GIS is just a GPS coordinate, but that GIS can connect a table of data to it, and that's where it holds the text information.
And so then you had to decide what words you're going to use to describe different sites so that it's uniform once you sort for like furniture production or paint or things of that type.
Yes, actually, thank you. That is a fantastic point. And that is part of kind of the learning aspect of it, that as I was collecting this data, before I really started collecting in earnest, and just so everyone knows, there were over 14,000 points that were collected. I didn't do it alone. I had a lot of help, and I'm very thankful for my help, mostly from my family. But it was a lot of data, and before I started doing that in earnest, I went through and I looked at the different type of data, and I decided what the categories would be, what the variety was, for exactly that reason, that you want to standardize it beforehand so that you don't end up with 14,000 points where the names and the building type are different.
Right, so you come up with a reasonable subset of keywords that are uniform across every type of business or map that you would look at.
Yeah.
Okay.
Yeah, and actually that's a really great segue. Let me share the website with you. That's a PowerPoint, excuse me. Okay, so you should see this, Paul, since you're at the top, can you just put your thumbs up if you can see my map? Okay, great, thanks.
I can see it, yes.
Okay, great. So this is the website that I created. Part of the benefit of using a GIS, like I said, how it brings all these different things together, all these different geographic processes. One of them is, and this is a newer thing, of course, is creating, you can use GIS, at least ArcGIS, it depends on the program, of course, to create a website to take this data and share it publicly. This website is not public just yet. I'm doing it through my university, and so I have to get it cleared through them before I can share it with the full public, but it should be in the next week or so. But this is the data that I collected. This is the city of Grand Rapids. This black dot is the city boundaries in the early 1900s. And these points are all the locations that were collected of industrial locations. So here, let me open it. So this is the layer list. And this, if you went to this website when it's live, you can do everything that I'm doing right now. This isn't because I'm the owner. This is anyone viewing this website would be able to do that. And so it's a really, GIS allows me to create this, but then once I create it, a user anywhere in the world, I can't guarantee anywhere in the world would want to do this, but certainly anyone in Grand Rapids could come here and look at this different information. So as Mike, as you mentioned, was kind of coding these points. Well, this was the general categories that I collected for all of them. And so as I went through the maps, I would categorize locations based on if they were an industrial building or a factory, if they were a warehouse or a storage building. So I can show you, I turn that off and turn this on. These are all the warehouse and storage buildings. These are locations of any type of, public building or a government building or a health building. It was sometimes hard. There were big categories. This was all the schools that existed, or the churches, and then all these other things. This one's, there's a lot of sheds. There were a lot of sheds and small structures. So these were all the locations. What I could do is that I could sort based on the activity that was happening at that location. So if it was varnishing furniture, or if it was an auto garage, I made another field, or a column like it would be in Excel, and identified the locations that could have been a contaminant risk back in 1912, that they might have been chemical contaminant, coal contaminant, and so that's how then I created this layer, and all of this data, everything that I'm clicking here, these are all from maps from the early 20th century, which is just so amazing that this information that exists, this map in 2020 was from, this information has not changed since the early 1900s, over 100 years ago. And so this identifies all the locations that could be a potential contaminated site. But further to Michael's point about how I can code all this is that and how it holds its data. So these are locations that are categorized as an industrial building or factory, but we also collected data, additional data that was present on the maps. And so this is interactive, so you can click on a location, and this, it holds this information that this location was actually a coal pile. And the categories you can see was industrial factory, and the potential contaminant at this location is coal. Let's click on, this was a concrete block factory. Let's go down here to DeVos Place. So, and then this one, not all locations had the same amount of data. This location actually had a company name. This was the Heyman Company, and it was furniture repair and woodworking. And the potential contaminants were a boiler or furniture. I say furniture isn't a contaminant, but furniture creation and works has potential contaminants through varnishing or special products that they use. And then here, this is Adolf Lightlet Iron Works. So, and then this is true for all these layers. So the church or place of worship, this shows what church it was. This was the Evangelical Lutheran Church. So this is an example that when I was doing my thesis, I wanted to, this was interesting to me, taking data from historical maps, using GIS and making this data digital and usable to people in the 21st century, but I also didn't want it to stay in a thesis. I wanted this data to be available for the public. We did all this work, and if it just stayed within a paper, let's be honest, anyone who's done masters or their dissertation, like 10 people are going to read your paper. So I wanted this information to be available to the public, and that's why I was using GIS. I was also able to create a website that you can go and look at this information. Okay, so I will stop sharing that. All right. And actually, that is all that I have for today. So thank you for joining in and listening. And I am ready to take any final questions that anyone has.
Will you be sharing this with any historical organizations in Grand Rapids, like the museum or any of those?
Yes, I will. And actually, thank you for mentioning that. I forgot a huge detail. So actually, and I'm embarrassed that I didn't say this at the beginning. The way that where this project came from was actually from another HASC presentation. About a year ago, Mark Worrell from the Michigan DEQ, it's not Michigan DEQ, now it's called EGLE, E-G-L-E, presented on the contaminants that are no longer there. So historical, where old gas stations used to be. And he's an environmental, he works in the environmental department, and he's been doing a lot with Wolverine, if any of you remember. And these locations that, of course, is in his role, all of a sudden, out of nowhere, this contaminant will show up, and they have to go and they have to find it. Whereas if we had a database of historic locations, like I said, we know where all the present polluters are, we can see them. But the things that in the past that have polluted our areas and left sites with contamination, we don't know where those are. And it's kind of, you know, the environmental planners, or not planners, I should say, but researchers, is that they don't really know until a problem shows up. And so what he was talking about is that there's this gap and this need for a historical database, or for a database on historical locations of industrial sites or of potential contaminated sites. And then listening to this and thinking that I'd have to do a thesis for my master's, I realized that this would be a really great opportunity. I love historical maps, and GIS would be a perfect way to do that. And so that was actually the inspiration for it. And so I'll be sharing this certainly with him, with Michigan DEQ, that this is data that they can use. And I'll be giving him the actual big database rather than just the website. But I also was in contact when pulling in historical data. I was in contact with the Grand Rapids Historical Archives. And there's another group, the name is escaping me. But it's related to the history of Grand Rapids. So I will be sharing this with them, definitely. And this is available to anyone, anywhere that wants to view it. Question, so Bill Wells, great, thank you, Bill, I'm glad you could join us. I'm Paul's daughter. We are actually in the same house right now, but we are calling in from different rooms. So yes, I was very fortunate.
Dana, one thing I noticed that I hadn't noticed before on the slide of renewable energy potential.
Yeah.
It's interesting that the highest ones are all grouped, and they're in the south of the U.S.
Yeah.
Is there an explanation for that? And it seems to me that they would be much more interested in utilizing that.
Yes, let's go back to that slide. here. Oh no, sorry, let me turn it. Oh no, okay. For some reason it doesn't, I'll just leave it like this instead of doing the full screen. Hopefully you can.
So the Southwest seems to be
Yes.
the best.
Yes, and but the thing, you know, to remember for this one is it is this isn't necessarily based on whether like the political or you know economic potential of renewable energy. This is, at least from what I can tell, this is like this is based strictly on the physical attributes. And so the areas that are the darkest are all kind of co-located, and that's because these areas, you know, geothermal energy potential will be linked to tectonic activity. Solar energy potential will, of course, be linked to the solar radiation and sunlight, which kind of also fits with the South and the West, the Southern Southwest. Wind energy, a lot of these states you have, you know, big flat plains, which are helpful. And then hydropower, that one's maybe not as good. Well, certainly Colorado, you know, and New Mexico and Arizona, you could have some hydropower. But it is true that it does seem that there's a certain geographic pattern to where the combined renewable energy potential is the highest. And this is also, just this image by itself is very helpful because if you just show it to planners, or if there's a company that's interested in this, then if they're you know, in Maine or something, they might want to consider not trying to invest in Maine specifically for a certain renewable energy, but maybe in the South or Southwest where they can combine these a little bit more effectively. But again, this is also the combined ones. In the tab, if you were in the live website, you could look specifically and at the different potentials, at type of renewable energy potential, and that will change where it is in the country. Any other questions? Well, I was actually a little worried about running over, but looks like we're okay. So if there are any more questions, you know, feel free to type them or ask them. Otherwise, thank you so much for listening in. It was a pleasure to present to you. Hopefully I've got you thinking about some things. If there's anything that you're interested in GIS, I do this even though this is my expertise. Sometimes I just Google GIS map and then whatever topic I'm interested in, and some really interesting options come up. So if there is something that you're interested in specifically, a quick search will bring up a lot of different options.
I just want to say thank you. And remember, everybody, there's only about 163 odd days till Christmas.
Thank you so much, Dana. It was a great presentation. I'm excited to share it with my 21-year-old environmental studies daughter, who is a little bit familiar with GPS from spending a semester in the South Caicos Islands doing some research. It was awesome to hear from you today. Thank you, Paul, for helping us set this up. Keep up the great work, Dana, and thanks everyone for tuning in. We will see you next time.
Great. Thanks.
Thanks.
Bye.
Bye.